Hello, welcome to this quick tech video on AXI USB 2.0 device IP. In this video, I will talk about key features, configuration options, block diagram description, and finally a typical application for this IP. But before that, let's talk about Xilinx Embedded IP Catalog. Embedded IP Catalog consists of off-the-shelf AXI4 based embedded IPs, which are easy to use, pre-verified, and highly configurable. These are available as part of Vivado design suite. It helps customers build their embedded system faster. It supports 7 series and Zinc families, and these IPs are based on industry standard AMBA AXI4 interface and can be connected to Zinc or Microblaze, which is 32-bit soft processor directly. It provides complete solution. Embedded IP from Xilinx is a complete solution. It provides RTL, standalone verification environment, standalone and/or Linux device drivers, APIs, libraries. As a part of documentation, we deliver product guide and application notes. Vivado API tool is provided as an integrator tool which can be used to configure the IPs, connect the IPs, and build a subsystem using Vivado design suite. Let's talk about a little bit of history of USB, which is Universal Serial Bus. The standard itself is developed and maintained by USB Implementer Forum, USBIF. The first version of it was introduced or published in January 1996, supporting low speed 1.5 Mbps and full speed 12 Mbps. It is subsequently followed by USB 2.0 standard in April 2000, which is backward compatible and adds a high speed 480 Mbps. Latest USB 3.0 standard was published on November 2008. It's backward compatible to USB 2.0 and increases the data transfer rate up to 5 gigabit per second, also called as super speed mode. It decreases overall power consumption and increases power output. Let's talk about AXI USB 2.0 device IP key features. This is based on AXI4 interface on host and application side, and on the PHY side it is based on ULPI or HSIC PHY interface. It also has optional DMA mode to increase throughput during data transfer, and it supports USB 2.0 high and full speed specification. Bus length support of 1 to 256 bits with INCR type transfer. It supports ULPI or HSIC PHY interface and supports up to 8 endpoints, out of which control endpoint 0 is supported and endpoints 1 to 7 can be configurable and supported as bulk, interrupt or isochronous. This IP also supports optional USB error detection, updates error count and generates error interrupt. Optional unaligned transfer support is also provided for AXI4 master interface. This is a licensed IP, so please contact a Xilinx sales personnel for the licensing terms and conditions, but it is free to evaluate. Now let's look at some of the configuration options. On the right hand side, you will see a configuration wizard for this IP, and on the left hand side of it, you will see a block showing the pin interfaces. Now the default option for this IP is no DMA support, no USB error counters, no include debug port. So in its default form, you will see only slave AXI interface, ULPI interface, clock and reset and interrupt. Now the optional features are enable DMA support. This enables internal DMA engine. So when you enable DMA support, M_AXI port becomes visible. Similarly, when you enable debug ports, the debug ports becomes visible on a port map. Now the debug ports include VBus detect, speed, suspend, etc. There is also enable HSIC PHY option, which when selected grades out ULPI PHY option. Enable USB error counter includes error counters for USB protocol errors. Now let's talk about a block diagram of this IP. As you can see on right hand side, you have 32-bit AXI interface. There is AXI slave interface through which AXI master like a DMA or a microblaze processor or Zinc can access register control logic. Through this slave port, a master can connect to USB slave device through AXI slave, DPRAM, SIE and ULPI-5 data path. As you can see, the DMA controller and AXI master interface is an optional interface. So when you enable that configuration option, the interface becomes available and device IP can act as a master. Similarly, HSIC-5 is also a configurable option, which when selected disables or grayed out ULPI-5 interface. So you can choose either a ULPI-5 or HSIC-5 interface. So both HSIC and DMA features are configurable. SIE is a serial interface engine which is used for serializing and deserializing data. DPRAM is dual port RAM for storage of data. And then there is a register and control logic. Continuing the block description discussion, AXI for host interface consists of two interfaces, master and slave. Master is an optional interface as seen before. It is used when DMA enable option is selected. It performs read and write transactions. Interrupts are generated based on DMA done. Slave interface is a default interface which is used for register read and write. It responds to AXI read write to 32-bit control register, status register and DPRAM. So data can be written to USB 2 device through this AXI slave interface. It supports byte, half word and word transfers for the DPRAM, but only word transfer are supported for the register. SIE, Serial Interface Engine. This is the block of logic which handles serialization and deserialization of USB traffic at the byte level. Multiplexing and demultiplexing of USB data to and from endpoints of the core. It handles USB 2.0 state transitions such as suspend, resume, USB reset, and remote wake up signals. 8-bit ULPI interface for ULPI or HSIC-5 interface is the PHY interface on the left hand side. So on the right hand side, it receives data either through control or register logic and through DPRAMs. And on the left hand side, it gets transferred to 8-bit ULPI interface. This IP has two DPRAMs, which are dual port block RAMs. It's used for data storage between SIE and AXI interface. Port A is for SIE, port B is for DMA and processor. Both the ports are 32-bit ports. DPRAM 1 is 64 by 8 bits. Control registers and reports the status of each FIFO buffer, and it also has endpoint 054. DPRAM 2 is 2K by 8 bits. 7 endpoints FIFOs are implemented for endpoint 1 to 7. On PHY side, there are two interfaces options provided by this IP. ULPI, which is the default option. Bit level serialization and deserialization of USB traffic happens. Detection and recovery of the USB clock. User need to connect external USB PHY for USB connectivity. So you take the ULPI interface, connect external PHY, and what you get is a USB D plus D minus USB connection. There is also high-speed interchip interface, which is an optional interface. You can either choose ULPI or choose HSIC interface. This is the industry standard for USB chip-to-chip interconnect for high speed only. 8-bit ULPI to 2 signal strobe and data HSIC interface conversion happens through this block. Source synchronous serial interface and supports only high speed data rate. User need to connect HSIC interface at the other end of the connectivity to complete the connection to the block. For a typical application example, we have developed XAP 891. This is a mass storage application, and on the right hand side you can see a typical block diagram. It has a processor subsystem which can be a microblaze or Zinc processor subsystem. Then it has AXI USB2 device IP, which is through ULPI interface connected to USB 5. There is also MIG IP through which it is also connected to DDR memory, and then couple of AXI GPIO and UART Lite IPs. So this is a typical block diagram of this application node. On slide below, just below the block diagram, what you will see is a snapshot of a board setup. So this is for Zinc ZC702. This mass storage application demonstrates bulk and ISOC transaction and performance metrics. This is MB based design for KC705 or Zinc based design for ZC702. It's developed using Vivado 2013.3 and using standalone application. So far we have seen a little bit of introduction of this IP. In order to use this IP with Xilinx Vivado design suite, there are additional resources available on web. Kindly check customizing and instantiating IP video or designing with Vivado IP integrator video, or there are few other tutorials available on Vivado. This will help you to use this IP in Vivado design suite and also help you integrate this IP with your design to create a subsystem or to create a final design for you. In summary, AXI USB 2.0 device IP is available as part of embedded IP catalog. This is part of plug and play Vivado IP catalog, which can be easily configured and connected using Vivado IPI tool. It provides USB 2.0 device functionality and can be connected to Zinc and microblaze soft processor. It is suitable for applications like mass storage, USB enabled keyboard or mouse, or microphone and speaker applications. Thank you for watching this video.